Our final two examples for some verifying trig identities. We're looking at number 29, and in my opinion, I would say the left side is still a little more complicated, although you could give some argument for the right side. But we'll go ahead and start with the left. On top, we have something that we can multiply out. So there's a couple different options here. I'm trying to think through what might be best for newcomers to trig identities. What I'm going to do, I'm just going to pick one and go with it. And here's what I see. On the top, I have a 1 plus sine theta. And actually, I already have a 1 plus sine theta. Well, except I have that squared on the left side. So what I'm going to do is I'm going to separate out that 1. I know I want the 1 plus sine theta. So let's go ahead and write this as 1 plus sine theta times 1 plus sine theta over cosine squared. Actually, I'm going to write that over here because really we're going to kind of think of this as a separated term. So we already have the 1 plus sine theta, which is what we want on top. How do we get what we want on the bottom? This is where it might take a little extra knowledge of knowing what's going on here. I want to probably cancel this somehow. Well, how do I cancel that with a cosine squared? Well, as mentioned before, cosine squared, maybe we want to look at Pythagorean identities. So I'm going to come down bottom right here, look at this Pythagorean identity that does involve a cosine squared, and I could solve for cosine squared and get that cosine squared is 1 minus sine squared theta. It's really small down here in the corner, and that's now got it in terms of sine squared. So my next step is I'm gonna keep the 1 plus sine theta. That's hopefully there for good. We want that in the numerator, and I'm going to multiply that by 1 plus sine theta over 1 minus sine squared theta. And we used Pythagorean identity. Above here, we just used the definition of an exponent of squared and wrote it as something times itself. Now, do you notice what's going to happen here? We have what we want on top. We want a 1 minus sine theta on the bottom. And here is what you need to use. You need to realize, highlighted in pink here, that this is a difference of squares, and we can factor it. We haven't done a lot of factoring, but in our second step, it says use identities, factoring, distributing, use some of those other things, but we haven't used factoring, but now we get our chance. So we still have 1 plus sine theta times another 1 plus sine theta over a difference of squared is 1 plus sine theta times 1 minus sine theta. So we factor that denominator. That was factoring. And we notice things cancel, and we actually get to our answer. Didn't leave myself quite enough room. And so we can write, and I'll show that these cancel. So this cancels with this. When we multiply, we get 1 plus sine theta on top, 1 minus sine theta in the denominator, which is equal to what we were trying to show. So that was simplifying. All right, and our last one, cosecant of theta times cosine squared theta plus sine theta equals cosecant theta. we have two terms that we want to be one term. When I see this, and maybe there's a better way to do it, but when I see this, I think, well, maybe I'll have to somehow add things. In order to add, I might need a common denominator. Right now, there are no common denominators, but I do know that cosecant is 1 over sine. So that's probably what I'm going to do, is change the cosecant to 1 over sine. We'll have a denominator, get a common denominator, and just see if things work out. In my mind, again, I mentioned this before, realize, hey, this cosecant is 1 over sine theta. So if we can get to 1 over sine, we're basically there. And let's get to it. I'm going to write this cosecant theta, so I'll still have my cosine squared theta over sine theta, because I can use the reciprocal identity, and that's like a 1 over sine plus sine of theta. That equals cosecant. And as I already mentioned, well, I'll say that was reciprocal identity. As I mentioned before, I'm going to get a common denominator. So on the left here, sorry, on the right, I need a sine theta over sine theta. You don't have to show this work. We can just put it in there. I'm showing it for your benefit here. So we're getting a common denominator, which will give us cosine squared theta plus sine squared theta over our common denominator of sine theta. Now we might see what's happening. What's in the numerator? We have a sine squared plus cosine squared. Hope you're getting that down by now. That's a 1. So we got 1 over sine theta, and 1 over sine theta is cosecant theta. And we showed that both sides, or that the left side is indeed equal to cosecant theta.